Hello friends, myself I am Harde, presently working in RSM Polytechnic Nasik. So today we will see the unit number 5, hydraulic turbine. So in that we see the Kaplan turbine, which is a type of reaction turbine. So let's start the Kaplan turbine. So first, what is the Kaplan turbine? So Kaplan turbine is an axial flow turbine. The water flows from runner of turbine in axial direction, and energy at the inlet of turbine is sum of kinetic energy and pressure energy. The basic difference in Kaplan turbine and Francis turbine is the runner construction. So in axial flow turbine, shaft is vertical. The lower end of shaft is larger, is known as hub or boss. It is a hub. On this hub, vanes are attached. If vanes are adjustable, then it is known as Kaplan turbine. If vanes is not adjustable, then it is called propeller turbine. So Kaplan turbine have adjustable runner blade that offer significant advantage and gives high efficiency in the range of partial load, and it is a little drop in efficiency due to head variation of load. So Kaplan turbine is suited for large quantity of flow. Kaplan turbine is named as V. Kaplan, which is an Australian engineer. Kaplan turbine widely used throughout in a high flow, low head power production. So, the firstly draw the figure. The working principle of Kaplan turbine is water enter into turbine through guide vanes and align such to give flow suitable degree of swirl. The flow from guide vanes passing through the curve, which is forces the radial flow in axial directions. The axial flow of water with component of swirl applied on the blade. So in Kaplan turbine, both linear and angular velocity are produced to the rotor. It is it is a hydroelectricity Kaplan turbine. It's same as that Francis turbine. So this is a runner, and this is the schematic views of Kaplan turbine. So firstly, what is a firstly draw the Kaplan turbine. Draw figure. Draw the figure. The figure shows reaction turbine. The shaft of turbine is axial. The lower end of shaft is made by larger, which is known as hub. The vanes are, the figure shows Kaplan turbine runner. The vanes are fixed on the hub, hence it is called axial flow turbine. The important types of axial flow turbine is propeller turbine and Kaplan. When the vanes are fixed to the hub, they are adjustable. The turbine is known as propeller turbine. But the vane on the hub are adjustable, then the turbine is known as Kaplan turbine. After the name of Kaplan turbine, the figure shows Kaplan turbine, which consists of hub. The main parts of Kaplan turbine is scroll casing, guide vane mechanism, hub with runner of the turbine, and draft tube. The figure shows all main parts of Kaplan turbine. When water from penstock enters to the casing and moves to the guide vanes. From the guide vanes, the water turns through 90 degree, which is shown in figure. So discharge through runner is obtained as outer, so it consists of DO and DB. DO is the outer diameter, DB is the inner diameter. And VF1 is the velocity of fluid inlet. So write down this. The figure shows guide vanes, scroll casing, runner vanes. The Kaplan turbine runner, which is shown in figure, it consists of shaft and having adjustable vanes, which is connected to the shaft. So write down the procedures, theories. झाली की मला सांगा. तुला आकाकडे जायचं नाही झोपायला. The figure shows Kaplan turbine. So Kaplan turbine is suited for low head, sorry. So the main diagram, construction diagram, is similarly this: scroll casing, guide vanes, water come from penstock. Only runner is different from France, as compared to the Francis turbine. So guide vanes, runner vanes. So turbine runner, when guide vanes come out from scroll casing, it impact on runner, and due to that it rotates, and this water get outlet from inlets. So this is a shaft of Francis turbine, a Kaplan turbine. This is a hub which is shown in figure. This is a vane which is used in for turbines. Next, this is a schematic views. In views, so water comes from guide vanes, that is movable vanes. When come from water this side, impact on vanes, due to that hub and shaft get rotated and gives the motions to the shaft. So next is a schematic diagram from Kaplan turbine. So it consists of generator shaft. So when water comes from outward sides, then water impact on vanes, due to that turbine get rotated. The red portion shows turbine with generators. So this is a Kaplan turbine. So next is a D by D ratio. It is a ratio of hub diameter to the diameter of runner. So DB is the diameter of hub diameter, DO is outer diameter. Next flow ratio psi, which is ranging from 0.35 to 0.6. Psi is equal to Vf1 upon root 2 GH. So Vf1 is equal to Vf2. So next speed ratio, Ku is equal to U upon twice root 2 GH, where U is equal to Ku root 2 GH. So U1 is equal to U2 is equal to pi dn upon 60. So Q discharge is equal to pi by 4 do by d minus square minus dB square Vf1. So write down this working proportions of Kaplan turbine. So next is a unit speed, unit quantities. So unit speed is the speed of turbine working under unit head. So that is a Nu is equal to N upon root H. Unit discharge Qu. So it is a discharge passing through turbine working under head. Next, unit power. It is power developed by turbine working under the head. So write down all quantities: unit head, unit speed, unit power. So firstly write down so today we have see the Kaplan turbine. So firstly, introduction of Kaplan turbine. The main parts of Kaplan turbine scroll casing, guide vanes, hub, then working principle. There is a runner of Kaplan turbine. This is a total diagram of Kaplan turbine. This is a pictorial views of Kaplan turbine. Next, this is the schematic views of Kaplan turbine. This is a schematic diagram from Kaplan turbine. Kaplan turbine. So this is a rotor and stator. This is a pictorial views how to water come from penstock and how to impact on. This is working proportion and unit. So today we will see the Kaplan turbine. In next lecture we see the draft tubes and cavitations.